Assalamu alaikum wa rahmatullahi wa barakatuhu. Hello, my name is Muhammad Salim Bhatt. I am from Kashmir in India, which is popularly known as Paradise on Earth. Regarding my education, currently I am pursuing PhD in the Department of Computer Science from Shri Venkateshwara University, India. My research topic is in the field of cloud computing, in which I am working on security issues and challenges to adopt cloud computing from small scale to medium scale enterprises. Also, I have completed my master's and bachelor's degree in the Department of Computer Science from University of Kashmir. Apart from this, currently I am working as a guest lecturer in various government colleges and higher education departments. Also, I am running my own computer training institute where we train students with various basic and advanced computer courses and guide them in their academic projects. Now let us start our topic, that is integral calculus geometry. Before we start our topic, we need to know the basic concepts about integral calculus geometry, that is differentiation and integration. What is differentiation? Differentiation is the process through which we find the derivative of an equation. The process to find the derivative of equation of an equation is called differentiation. In simple terms, if we define the differentiation, then we can say differentiation is to differentiate or breaking down an equation into smaller pieces so that we can find the accurate result of an equation. Okay? Next thing is, in mathematics we use some symbols. Means when we are differentiating equation, we use some symbols that denotes that we are differentiating this equation. These symbols are like dy by dx, or we can use y dash, or we can use f dash x. These are the symbols that we are using when we are differentiating an equation. Both three symbols can be used as a differentiation symbols. Now the concept is how we differentiate an equation. How we differentiate an equation. It's a two-step procedure. It's a two-step procedure. Two steps have to be followed when we are differentiating an equation. First one is first step, bring the power to the front. And second step is subtract 1 to the power. For example, if we understand this procedure, we take an example, we take a general equation that is x raised power n, so that we can understand how the equation will be differentiated when we are dealing with the differentiation. This is the general equation where we are using the x raised power n. The first step, bring the power to the front. Here the power, we are using the variable x with power n. With power n. And then the equation will be nx. This is the first step. Bring the power to the front. To multiply to the variable, that is x. And the second step is subtract 1 to the power. Means power is n, that means it will be nx raised power n minus 1. This is the differentiation of the general equation, that is x raised power n. That is nx n minus 1. Let's take another example, x raised power 4. Here add and we take the raised power 4. If we differentiate this equation, then we can write, first step is bring the power to the front, that is 4x, and the second one is subtract 1 to the power. Here power is 4 and we subtract 1, that is minus 1. Then the equation will be 4x raised power 4 minus 1, that is 3, that is cube, 4x cube. We take another example, that is x raised power 6. Then it will be 6x raised power 6 minus 1, that is 6 raised power for x raised power 5. These are the simple differential equations when we are differentiating an equation. We are taking some steps, only 2 steps. First one is bring the power to the front, to multiply to the variable, that is x, we are dealing with the x. And the second one is subtract 1 to the power. That power, once we take n, that is n minus 1. In another example, we take 4 as power, that is 4 minus 1, that is cube. And the next one is 6 power, that is 6 minus 1, that is raised power 5. This is the basic concept about differentiation. Now the next question is applications of differentiation. Applications of differentiation. Differentiation is used in economics as well as businesses to find the optimal solutions. Differentiation is used in economics and in businesses to find the optimal solution. To find the optimal solution. For example, to use the minimum amount of material to make the packaging, or to maximize efficiency of products, or we can say to minimize their costs. This is the general concept regarding differentiation. Now we'll go to the integration. Now let us discuss integration. What is integration? It is a process of finding the antiderivative of a function called as integration. Or we can say integration is the reverse process of differentiation. Now here integration, we use the mathematical symbol as like this, f of x dx. where this is the integral sign. This f of x is called integrand, and this d of x, it tells us the variable of integral. Basically, this is the general notation of integration, where this is a sign for integration, the symbol we are using to denote that we are doing the integration to this equation. Here, when we are doing the integration, we have to follow the procedure. As like in differentiation, here in integration, we have a two-step procedure when we are doing integration to an equation. For example, if we take an example just like x raised power n, first we will see what are the two steps to be followed when we are doing the integration process. The first step, that is add 1 to the power. And the second step is divide the power, that is the new power. Divide the new power to the equation. For example, just here I take the equation x raised power n. X is the variable and n is the raised power. If we follow the integration process here, first the step is add 1 to the power. It means x n plus 1. And the second step is divide this new power, that is n plus 1 here, to the equation. It will be x n plus 1, that is raised power n plus 1, divided by n plus 1. This is the basic concept we are dealing with the integration. For example, we take another example here, that is x raised power 5. If we use the notation, integration notation, that is this, and we have to use as well as dx for these equations. Here we do the first step, that is add 1 to the power, that is x, the power is 5, it means 5 plus 1, and divide this power to this equation, that is 5 plus 1. It means the equation will be x, that 5 plus 1, that is raised power 6, divided by 5 plus 1, that is 6. It means the antiderivative of x raised power 5 is x raised power 6 divided by 6. This is the antiderivative of this equation. Or here, that is x raised power n, its antiderivative is this. This is the general procedure when we are dealing with the integration process. If we take another example, just like x cube plus 3x square plus 5x. If we integrate this equation like this, d of x, it will be, we have to divide these equations in number of equations as like this, x cube dx plus integral sign 3x square dx plus integral sign 5x dx. And at last we are using plus c. This is the equation that is called the indefinite integral calculus. The next step is we follow the procedure. First one, that is add 1 to the power. It means x cube plus 1 divided by that power, that is 3 plus 1. And the next will be plus 3x square. It means 3x 2 plus 1 divided by 2 plus 1. The next one is plus 5x, that means x is raised power 1 is already, when nothing is seen on the raised power, it will be 1. That means 5x raised power 1 plus 1 divided by 1 plus 1. And lastly it is plus c, where c denotes the constant. It is any constant. We'll solve. The next step is x raised power 3 plus 1. It will be x raised power 4 divided by 4 plus 3x 2 plus 1. That means 3x raised power cube divided by 2 plus 1, that is 3. Plus 5x raised power 1 plus 1, that is 5x square divided by 1 plus 1, it will be 2. And lastly it will be the c, that is the constant value. Here x raised power 4 divided by 4 plus here 3 and 3, it will be cancelled. It will be x cube plus 5x square divided by 2 plus c. This is the final solution of this equation, or we can say the antiderivative of this equation is this x4 divided by 4 plus x cube plus 5x square divided by 2 plus c, where c is the constant. Why we are using the c in indefinite when we are dealing the indefinite integral calculus geometry? For example, if we take a simple example as x cube, its antiderivative will be x 3 plus 1 divided by 3 plus 1. It will be x raised power 4 divided by 4. Or the next one, if we change this equation with a constant value as x cube plus 5, the antiderivative for this equation will be x like this, x cube dx plus into the sign 5 dx. It will be x cube plus 1 divided by 3 plus 1, that is power, plus the integration sign of 5 dx is 0. Then the equation at last will be x raised power 4 divided by 4. See here, when we are using the equation as x cube, the antiderivative will be x raised power 4 divided by 4. And when the equation is x cube plus 5, then the antiderivative is same as the previous equation. That is why we are using the equation when we are dealing in the indefinite integral calculus. Then at last we are using the c, that denotes the constant. That denotes the constant. You will lose points or marks when you solve the integration process and you does not write the dx or c. That means you are not perfectly solve the equation with the procedure as in integration. Now we will go for the next topic that is related with this, that I have used with this calculus concept. What does it mean? Calculus. What is calculus? Differentiation and integration together is called calculus. Both these concepts are combined together, and then we can say we are dealing with the calculus geometry. Two types of calculus geometry we are here in integration. One is that is already discussed, that is indefinite integrals. Indefinite integral calculus, and another one is definite integral calculus. As we have already discussed in indefinite integral calculus, the general notation is like use the sign, integral sign, f of x dx. This is the general notation, and we are using at this equation with c plus c, that denotes the constant value. While in definite integral calculus, when we are dealing this, at that time we are using the limits. Means we use the upper limit and we use the lower limit. Just like if we show the definite integral calculus equation, it will be like this: f of x dx, and we show the upper limit and the lower limit with the sign. The upper limit is here b and the lower limit is a. And then the equation, when we are dealing the definite integral calculus, first we find the derivative of this equation as in indefinite integral calculus, and after that we give the limits to this variable. Here we are using the variable that is x. It will be like this if we denote this definite integral like as f of x, like this. Here b and a, while b is the upper limit and a is the lower limit. And the next step is, for this limiting, we are using this f of b, as we are denoting both these values, both these limits, the upper limit and the lower limit, that is x with this b value, and then the lower limit, that is a limit. Means upper limit minus lower limit. This is the general concept regarding when we are discussing the basic concepts about the integral calculus geometry. So, hope you understand this topic. Thank you. Fi Amanillah.